This video compares the Light-o-Rama Pixie 16 version 4 and the Holiday Coro Alpha Pix Flex-based controller from Holiday Coro. Let's go through each one of the features that's on the controller and compare the two together so you can see that these are two totally different systems. Let's start off with power. So, these controllers both have two banks, as you can see here, two banks, four connectors, and that allows us to split one bank of power to one side and one bank of power to the other side. Now, there's two very different types of connectors here. Now, on the Light-o-Rama controller, we have a fairly inexpensive connector, and what this does is it has a screw terminal that's raised up off the board, and this requires that you not put a bare wire into here, but you have to use a spade or loop type connector. So what you need to do is take your wire, crimp on another connector, then attach it. Now, in this particular case, on the Alpha Pix controller, we have a crush connection. So we can actually use spade connectors if we want. We just unscrew this, slide in the spade connector, or we can put bare wires up to 2 on each unit. And this matters. Why? Because you have to stack some of these in certain cases on the Alpha Pix, which allows you even more functionality. Okay, so we have two banks, both the same on each one, different connectors, Alpha Pix, easier to connect. Now, on the outputs themselves, we have fuse connections. These are both standard mini blade fuses. Now you'll notice that these are pink and that these are brown, and that's because the pink color indicates 4 amps per output, and here on the Alpha Pix we have 5 amps per connection. So we already have 20% more output possible on this controller. Now, in addition to that, the Alpha Pix on the board, it's not possible to see this without it powered up, but there are blown fuse indicators for each individual output. So if a fuse is blown, you don't have to look in there and try to pull them out. You'll immediately see that one of the lights is not lit up, and you'll know that that fuse has been blown. All right, moving on, we have the boards themselves. You can see that the boards are physically different sizes, and you can see that the Alpha Pix Flex is a smaller board. And there's a reason for this. And this is because when this controller is mounted into an enclosure such as the CG1500, which is extremely common, this allows us to put a power supply up here, but still leave space so that we can get the screw terminals in and screw that enclosure to a substrate, like a wall. So having a smaller footprint is definitely better. Now, let's talk about those actual outputs. Now you'll notice that in the in the Pixie 16, that the connectors are split on each half of the board. Now this was a way that was typical in the past. It's easy from a layout standpoint. The problem with that is that all the connectors have to connect on one end. So what happens is when we're building a controller, show you a controller that's already assembled, for example, what we have is we want all of these connectors to be in one place so that the cables, when they're at the end, aren't all different lengths. So it allows us to have a much cleaner setup, and that allows us to have much more space. We don't have cables running all over the place. So the fact that they're all in nice, neat rows is a real advantage. Now, in this case, you can see that we've got very clear, bold lettering on the indicators for each output, and each output is shown here, so that if you're trying to track back a problem, maybe you've plugged something in the wrong spot, it's very easy to see, even if you've got cables plugged in. The Light-o-Rama has smaller labeling on here. Now, both do feature silk screen showing you the positive clock data and negative connections, and that is also shown here on the Alpha Pix below the numbers. Okay, now they both do feature pluggable Phoenix style connectors, so you can assemble the connection off the board and then plug it in. This is also useful for troubleshooting, and they both feature this same functionality. Now, let's talk about some of the basic interfaces. So this unit uses RS45. This is a technology from the early 1970s designed for industrial systems, and it was really a great thing back in the 70s and 80s. And in the late 1990s, Light-o-Rama, when they designed their system, designed it primarily around RS45. Now, this is great when we have very low amounts of pixels, or as it originally was designed for, just 16 channels. Now it's not uncommon to have pixel megatrees with thousands of pixels on them, and that means that this kind of interface is not suitable. Now, it is a Cat5 jack, but that does not imply that that is what is called Ethernet. So this is a RS45 connection. Now, that means that our total bandwidth on this controller is roughly somewhere between 500 kilobits and 1 megabit. So if your regular cable modem is 50 megabits a second, that is 1/50th the speed of your cable connection. So this is something you would have had back in the day with dial-up and that type of thing. So very low bandwidth. Now, on the AlphaPix, we have Ethernet. Ethernet is 100 megabits, so it's 99 times more capacity than the LOR unit. Also, we have longer distances, so even at that maximum output of around a megabit, you can only go short distances without having problems. With Ethernet, we can go 300 plus feet with no problems. We can also daisy chain. You'll see that there are 2 plugs here. This allows you to come from one unit, daisy chain out to another Pixie type controller or Light-o-Rama controller, either on an LOR standard network or enhanced network. And the AlphaPix also features 2 Ethernet jacks, which is basically a switch inside. So, in terms of capabilities, there is no comparison. This controller has the ability to control a very small number of pixels, in the hundreds. This is able to control tens of thousands of pixels. So, now, let's go on to the actual operation. Now, you'll see that there's some jumpers on here, and they're not even labeled. They don't really give you any indication. Also, there's a switch bank here that you can't switch without really, trying to get that in your finger, and it's hard. You need a little tool to do that. That sets the address of the unit. So it's completely manual, so you may need jumpers to set certain settings, or you may have to adjust this setting. Now, on this controller, it's completely modern. We have a OLED display that allows us 4 lines of characters to set all the settings right from this 5-button interface. So it's in perfect regular English, nothing to understand. You just go in, click, and you can implement any settings you need. Now, that also can be accessed via web interface because it's basically a controller. It's a web-based device or Internet of Things type controller. That means once you've had it hooked up to your network, you can just connect to it and you can do all kinds of things. Invoke a test mode, you can change the settings, you can look at the settings. All that's very easy to do here as opposed to the Light-o-Rama controller board, which you need a separate piece of software that's unique to Light-o-Rama to do. So that really ties you in to the Light-o-Rama system. You have to stay in this area, as where this system is completely standards-based. Now, moving on, this controller is stackable. So we actually have the ability to add 3 different expansion boards. This is only one for comparison here to make them somewhat equal. It does have the ability to add multiple expansion boards. So you could add up to 48 outputs with one CPU. Additionally, this controller has 2 RS45 outputs. So the same kind of technology here is also here for legacy-based devices based on DMX. Now, some additional other items. We do have a power LED here on the power board, and up on the CPU board, there is also a power indicator here to show that it is powered up. So, in this example, you can see that the Pixie board is a far, far distance away from even a basic AlphaPix setup. These are 2 totally different worlds and 2 totally different types of controllers with different capabilities. The Light-o-Rama would be useful if you're in a purely Light-o-Rama network and you want to stay that way, and you have very minimal projects, right? Not big mega trees, not matrix panels, those types of things. You have a few things here and there with, 50 pixels or so, no problem. This will probably be fine. And for larger items, bigger displays, more configurability, more expansion, you're able to use the AlphaPix. And just for reference here is also the Pixie 8. This is the same kind of board. It's just 8 outputs. Now, there is a minor difference here. It does feature actually a better connector. So it would have been better if they probably actually had used this type of connector here than their connector here. So the ideal connector in these is this, then this. These sometimes have a problem with not crushing correctly the wire to get a good enough connection, and then finally this.